Welcome to another lesson of Math 0420 Introductory Algebra. In this video, we will be discussing section 1.7, multiplying and dividing real numbers. In this section, we will multiply real numbers, multiply more than two real numbers, find multiplicative inverses, use the definition of division, divide real numbers, simplifying algebraic expressions involving multiplication, and determine whether a number is a solution of an equation. Let's jump right in. Let's first talk about properties of multiplying real numbers. The first is that the product of two real numbers with different signs is negative. In other words, if you have two factors in a product, one is negative and one is positive, then your answer will be negative. Okay? The product of two real numbers with the same sign, in other words, either both positive or both negative, give us a positive number. Okay? And then finally, the product of 0 and any real number is 0. So if one of your factors in a product is 0, then the answer, the product, is 0. Let's do an example. Example 1. We want to multiply. In part A, we have 8 times negative 5. Well, each of our factors here has a different sign. The 8 is positive and the 5 is negative. 8 times 5 is 40, and since we have different signs, it's negative. Part B. Negative 12 times negative 3. Well, those have the same sign. They're both negative, so that means we'll end up with a positive number. And 12 times 3 is 36. Part C. We have negative 543 times 0. Well, if you remember, anytime 0 is a factor of a product, that product is 0. So that's what happens when you multiply two real numbers together. Okay, let's now talk about what happens when you multiply more than two real numbers together. Okay, multiplying more than two numbers. The first thing we need to do is to assume none of the factors are 0. Okay. Then the product of an even number of negative numbers is positive. The product of an odd number of negative numbers is negative, and if any factor is 0, the product is 0. Example 2. Multiply. Okay, for part A, we have negative 2 times 3 times negative 1 times 4. So how many negative numbers do we have? Well, we have a negative 2 and a negative 1. So we have two negative numbers. That's an even number, so our final answer is going to be positive. 2 times 3 is 6, times 1 is 6, times 4 is 24. And again, since we have an even number of negatives, we end up with a positive as our final answer. For part B, let's try negative 1 times negative 3 times 2 times negative 1 times 5. Let's count the number of negative numbers. We have 1, 2, 3. That's an odd number. So since we have an odd number, our final answer will be negative. We take the numbers. 1 times 3 is 3, times 2 is 6, times 1 is 6, times 5 is 30. So we end up with a negative 30 as our final answer. Let's now move on and talk about multiplicative inverses, and we'll start with the definition of multiplicative inverse. Finding multiplicative inverses. Definition. Two numbers whose product is 1 are called multiplicative inverses. So when you take two numbers and multiply them together and you get 1, those are multiplicative inverses. Okay, let's do an example. Example 3. We want to find the multiplicative inverse of each number. Okay, part A, we have the number 7. So what would its multiplicative inverse be? Well, we know that the product of 7 and some number is equal to 1. Well, the way we do that is we flip it, we find the reciprocal, and 1 over 7 times 7 is equal to 1. Okay, so our answer is 1 over 7. That is the multiplicative inverse of 7. Okay, same thing here for 1 over 8. Well, instead of 1 over 8, we flip it. So 1 over 8 times what gives us 1? Well, that's equal to 8. So our multiplicative inverse in this case is 8. And one last option, one last example, negative 7 over 13. There we go, negative 7 over 13 times what gives us 1? Well, you flip it. And so that's negative 13 over 7 is what gives us 1. So negative 13 over 7 is our multiplicative inverse. Okay, that's all for multiplication for now. Let's now move on and talk about division and defining division. Okay, division. Start with the definition. So if A and B are real numbers, and B is not 0, then the quotient of A and B is defined as A divided by B is the same as A times the multiplicative inverse of B, which is 1 over B. Okay, let's do an example. Example 4. We want to use the definition of division. Okay, the first one, negative 28 divided by 7. Well, that's the same as negative 28 times 1 over 7. And if you plug that into your calculator or rewrite it as multiplication, we end up with negative 28 over 7, which is negative 4 when you do that division. Okay, part B, negative 16 divided by negative 2. Well, that's equal to negative 16 using the multiplicative inverse times negative 1 over 2. Negative 16 times negative 1 over 2, both factors are negative. 16 times 1/2 is 8, so we get the positive version of that. Okay, let's now move on and discuss the quotient of real numbers and some properties of quotients. The quotient of real numbers. So some properties. The quotient of two real numbers with different signs, just like multiplication, is negative. Same sign, just like multiplication. The quotient of two real numbers is positive. Division of any real number by 0 is undefined. If you plug that into your calculator, if you try and divide something by 0, it will probably say error or undefined. That does not have a quotient. Things mess up when we try and divide by 0. Now, on the other hand, 0 can be divided by any number. Any non-zero number divided into 0 is 0. Okay, now that we've talked about properties of division, let's now talk about some additional properties of multiplication. Properties of multiplication. So this is a definition. Let A be a real number variable or algebraic expression. Then the identity property of multiplication that a times 1 is equal to a, and that 1 times a is equal to a. This means that any number times 1 is itself. Also, that's the identity property. The inverse property of multiplication should be inverse property of multiplication states that a times 1 over a, its multiplicative inverse, is equal to 1, and that 1 over a times a is equal to 1, so long as a is not 0. The multiplication property of -1 states that -1 times a equals -a, and that a times -1 equals -a. In other words, if you put a -1 times any number, it's the negative of that. And then finally, the double negative property states that the negative of -a is just equal to a. Basically, if you take the negative of something, you end up with just what you started with. Okay, negative signs in parentheses. So if a negative sign precedes, comes in front of, parentheses, it is assumed to be a -1. And you can remove the parentheses. And change the sign of every term within the parentheses. For example, if I have negative quantity 11x plus 5, I can drop the parentheses and distribute the negative. So negative 11x, and distribute the negative to the 5, and I get -5. Okay, let's now talk about simplifying algebraic expressions and an example. Simplifying algebraic expressions. Okay, example number 4. Oh, example number 5. We want to simplify. What we want to do is -4 times 5x. Okay, so we can distribute -4 times 5. One's positive, one's negative, so we get -20 times that. What if we had 9x plus x? Well, that's 9x plus 1x, so we get 10x. What about the negative of the quantity 7y minus 6? This is one of those where we assume that the negative is -1. So we distribute that to the 7y, and we get negative 7y, and then we distribute it to the negative 6, and so we change the sign to a positive 6. Okay, one last example here. If we have 4 times 3y minus 7 minus 13y plus 2, we can first distribute the 4 to the 3y to get 4 times 3, which is 12y, 4 times negative 7, which is negative 28. Then we can distribute this negative to get negative 13y, and then minus 2. Then we can combine the 12y minus 13y. 12 minus 13 is negative 1, so negative y. Negative 28 minus 2, when we distribute, we get a minus 30. Okay, that's example number 4. Let's try one more example where we determine if a number is a solution to an equation. Example 6. Determine whether negative 3 is a solution of 2x minus 5 equals 8x plus 7. Okay, so we can plug in our x value of negative 3 everywhere we see an x. So we have 2 times negative 3 minus 5. We don't know for sure if it's equal in this case. We're checking to see if we have a true statement. 8 times negative 3 plus 7. Plus 7. So we can now do that arithmetic. 2 times negative 3 is negative 6 minus 5. Again, we're checking to see if it's equal. 8 times negative 3 is negative 24 plus 7. And so negative 6 minus 5 is negative 11. And is that equal to negative 24 plus 7? Well, negative 24 plus 7 is negative 17. So those are not equal. So since this is a contradiction, in other words, not a true statement, because negative 11 can never be equal to negative 17, we have that x equals negative 3, the value we're checking, is not a solution to the equation. That is the end of section 1.7, multiplication and division of real numbers. Good luck on your homework. Please let me know if you have any questions, and I'll see you in the next one.